Welcome to my channel, Worldwise. Everybody is looking for the next big adventure. Humanity has always looked to the stars. Mars, our red neighbor, has captivated our imagination for centuries. Now it's on the brink of becoming a second home for humankind. Why Mars? The answer is threefold. First, Mars holds scientific treasures. It offers a unique opportunity to study the history of our solar system and the potential for life beyond Earth. Second, the human spirit thrives on exploration. Reaching Mars is the ultimate adventure, pushing the boundaries of human ingenuity and courage. Finally, and perhaps most importantly, Mars represents a safety backup for humanity. Earth is vulnerable to catastrophic events, from asteroid impacts to climate change. Establishing a self-sustaining colony on Mars ensures the survival of our species. This is not science fiction. This is the future we are building. The journey to Mars is a complex endeavor requiring meticulous planning and cutting-edge technology. While timelines have shifted over the years, the goal remains clear: to establish a permanent human presence on Mars. Current estimates suggest that the first human mission to Mars could launch as early as 2029. This mission will lay the groundwork for future colonization efforts, focusing on essential tasks such as establishing habitats, testing life support systems, and conducting scientific research. Subsequent missions will build upon these initial steps, gradually expanding the colony's infrastructure and capabilities. The journey will be long and challenging, but the rewards are immeasurable. Mars represents the next giant leap for humanity, a testament to our resilience, ingenuity, and unwavering spirit of exploration. Mars is a harsh mistress. Its thin atmosphere, composed primarily of carbon dioxide, offers little protection from the sun's radiation. Temperatures fluctuate wildly, plunging far below freezing at night. Water, essential for life as we know it, is scarce, locked away as ice beneath the surface. Dust storms, some spanning the entire planet, pose a constant threat. These are just some of the challenges that make Mars a formidable environment for human habitation. Overcoming these obstacles will require innovative solutions and a deep understanding of Martian conditions. From radiation shielding to resource extraction, scientists and engineers are working tirelessly to develop technologies that will enable humans to not only survive but thrive on Mars. Despite the challenges, Mars possesses surprising similarities to Earth. Its day-night cycle, known as a sol, is just over 24 hours long, mirroring our own planet's rhythm. Mars also experiences seasons, albeit more extreme due to its elliptical orbit. Evidence suggests that Mars once had flowing water on its surface, hinting at a potentially habitable past. These similarities offer hope and inspiration. They suggest that with ingenuity and determination, we can transform Mars into a second home for humanity. Just as life on Earth adapted to diverse environments, so too can we adapt to the challenges of Mars. By harnessing the power of science and technology, we can create a sustainable and thriving Martian civilization. Section 5, Lessons from Orbit, the ISS, a Martian blueprint. High above Earth, the International Space Station, or ISS, orbits our planet, a shining example of international collaboration and human ingenuity. This massive structure, assembled piece by piece in the vacuum of space, represents the pinnacle of human engineering and cooperation. The ISS also serves as a crucial testing ground for technologies that will be essential for Mars colonization. From life support systems to radiation shielding, every aspect of living in space is meticulously tested and refined here. One of the most critical aspects of living in space is creating a closed-loop life support system. This system ensures that resources are reused and recycled, minimizing the need for resupply missions from Earth. The ISS excels in this area, recycling approximately 98% of its water. This means that almost every drop of water is purified and reused, a vital capability for long-duration space missions. This remarkable feat is achieved through a combination of advanced filtration, purification, and even capturing moisture from the air. These technologies ensure that astronauts have a continuous supply of clean water. Oxygen generation on the ISS relies on electrolysis, a process that uses electricity to split water molecules into hydrogen and oxygen. This method is not only efficient but also crucial for maintaining a breathable atmosphere. The oxygen is used for breathing, while the hydrogen can be combined with carbon dioxide to create methane, a potential fuel source. This dual-purpose approach maximizes the utility of available resources. The ISS demonstrates that closed-loop systems are not a futuristic dream but a present-day reality. These systems are continuously monitored and improved to ensure their reliability and efficiency. By studying and refining these systems, we gain invaluable insights for building self-sustaining habitats on Mars. The lessons learned from the ISS are paving the way for humanity's next giant leap into the cosmos. Section 6. Breathing life into Mars MOXIE and the quest for oxygen. One of the most pressing challenges for Mars colonization is the lack of breathable air. Without a reliable source of oxygen, human life on Mars would be impossible, making this a critical issue to solve. The Martian atmosphere is extremely thin and composed primarily of carbon dioxide, making it toxic to humans. This means that astronauts would need to carry their own oxygen supplies, which is not sustainable for long-term missions. To address this challenge, NASA developed MOXIE, the Mars Oxygen In Situ Resource Utilization Experiment. This innovative device aims to create a sustainable way to produce oxygen on Mars. MOXIE is a groundbreaking device currently operating on the surface of Mars, attached to the Perseverance rover. It represents a significant step forward in our quest to make Mars habitable. Its mission is to demonstrate the feasibility of producing oxygen from the Martian atmosphere. If successful, this technology could be scaled up for future missions. MOXIE works by collecting carbon dioxide from the air and then heating it to extremely high temperatures, around 800 degrees Celsius. This intense heat is crucial for the next step in the process. This process, known as solid oxide electrolysis, separates the oxygen from the carbon dioxide. The oxygen can then be stored for future use, while the carbon monoxide is released back into the atmosphere. While MOXIE is a small-scale experiment, its success has profound implications for Mars colonization. It paves the way for larger systems that could support human life on Mars. It proves that we can generate breathable air directly from the Martian atmosphere, reducing our reliance on resources transported from Earth. This breakthrough brings us one step closer to making Mars a second home for humanity. Section 7. Beyond MOXIE, the future of oxygen production. While MOXIE represents a significant leap forward, scientists are constantly exploring even more efficient and sustainable methods for generating oxygen on Mars. One promising avenue of research involves using plasma technology. Plasma, often referred to as the fourth state of matter, is a highly energized gas that can be used to break down molecules. By applying plasma to carbon dioxide, scientists believe they can separate oxygen atoms more efficiently than with current methods. Another approach focuses on developing catalysts that can accelerate the breakdown of carbon dioxide at lower temperatures, reducing energy requirements. These advancements in oxygen production technology are crucial for creating a self-sufficient Martian colony, one that can generate its own breathable air and reduce its dependence on Earth. Section 8. Building a new home step by step on Martian soil. The process of building a Martian colony will be a gradual one, requiring careful planning and execution. Initial missions will focus on establishing basic infrastructure such as habitats, power sources, and communication systems. As the colony grows, so too will its capabilities. Three-dimensional printing technology will play a vital role in constructing structures, utilizing Martian regolith, the loose rock and dust found on the planet's surface. Greenhouses will be essential for cultivating food, providing a sustainable source of nourishment for the growing Martian population. Water extraction from underground ice deposits will be crucial for drinking, irrigation, and oxygen production. Step by step, brick by brick, we will transform the Martian landscape into a habitable environment, a testament to human ingenuity and perseverance. Section 9. A giant leap for humanity, the Martian future. The colonization of Mars is not merely a scientific endeavor, it is a defining moment in human history. It is a testament to our relentless curiosity and our unyielding spirit to explore the unknown. It represents a fundamental shift in our relationship with the cosmos, from passive observers to active participants in shaping our destiny among the stars. This monumental step forward will redefine what it means to be human. Imagine a future where children born on Mars gaze up at a rusty red sky, their eyes filled with wonder as they learn about their ancestors who dared to make this alien world their home. These children will grow up with a sense of adventure and possibility that is unparalleled. Imagine a thriving Martian civilization, a beacon of human ingenuity, pushing the boundaries of science, technology, and art. This new society will be a melting pot of ideas and cultures, united by the common goal of survival and progress. This is the future we are striving to create, a future where humanity is not confined to one planet, but is a multi-planetary species exploring the vastness of space. The journey to Mars will be long and arduous, but the rewards are immeasurable. The challenges we face will only make us stronger and more resilient. It is a journey worth taking, a giant leap for humanity that will inspire generations to come. The legacy we leave on Mars will be a testament to our courage and our vision for a better future. Watch my next video now.